Hi all, and welcome back to my Desynced programming tutorial series. Today's scripts are all about high mix construction. No good for throughput, but I find these very handy for building whatever it is that I haven't automated yet. And they're some of the very first scripts that I get running when I start a desynced run. I call these build as needed and build assistant. So let's take a look at how they work. So right now I have a pretty sparse base and I've literally not automated anything yet. Or in preparation for this video, I ruined a whole bunch of automation. You'll never know. But in either case, what I'd like to start doing is building a solar panel field, and I don't have solar panels being built anywhere, at least not explicitly. I find it fun to put my solar panels right in the shadow of large plateaus. And so that's what I'm going to do here. I'm going to put one down, and I'm going to put a couple copies of it all around this signal tower. And then I'm going to come back to these two scripts that are doing build as needed, these two buildings that are doing build as needed. And what they're doing is they're identifying that these construction sites need ingredients that aren't available in the network already, and going ahead and manufacturing them. So this one is currently building a capacitor. This one is currently building solar cells. And if we let it run, it should actually fulfill all of the needs of this set of buildings over here. All right, let's take a closer look at how build as needed actually works. Again, I have pseudo Python code over here in this text window to make it easier to follow along. The first step in this code is to identify a building that might need some construction help. We do this with a pair of loops, one which checks LoopEntitiesRange to do visual range. This is going to be things that are right next to the building. And two, we then ask our signal tower network to see if there's any buildings that they've identified and flagged for us through their network. In either case, these are going to execute the same subroutine. Once we have a building, we're going to loop over all of its recipe ingredients one by one to see if it needs any help with that ingredient. What's really nice is that this updates pretty quickly, and it includes not just the building itself, but anything that's included in the blueprint. It then checks whether this can be produced, and this is a little bit of a confusing instruction here. Can produce only checks whether the building that this code is running on happens to have a unit that can construct the item, but it has nothing to do with whether or not you've already researched the item. This means that if you're building with blueprints from a previous run, those blueprints might include items that you haven't yet unlocked, and they'll get stuck right here. If that happens, you'll have to manually clear it. Next, we check how many items are actually needed. We do that by checking how many are in storage with faction item amount, doing a quick subtraction, and that tells us how many are needed for the current building for the current recipe. If it's greater than 0, then we'll go ahead and build that. Let me just move this. To build, we're going to set our assembler to build the item, and then this loop should keep us locked in there until it's completed. What's nice about doing it this way is that each time it pulls that from the register that's visible to you when you're not in this code. And so if you just right click, you can clear that value out. Now I have this hard coded to only use assemblers, and arguably I should have popped open an extra parameter and let you choose which one of those that is. I find in my own playthroughs it was more convenient to just hard code this because honestly I haven't used this on other items yet. Maybe that will change, and if so, that's how you would do it. The last little bit of code is just to clear out all those registers so that if we're idling, there's nothing left, so there's no confusing visual experience as you're going through. During the time it took to take a look at that, all of our solar panels are built, and we're doing well. Now, again, this only can help us with things that are buildings that are being built, and it can't really help us with any sort of robots. So let's take a look here. If I were to go ahead and build, let's say, a Stabby Scout. Right away, I'm going to get my circuit boards. I have a capacitor ready, and oh, I haven't built any sort of small turrets yet, and it's just going to block on this. These scripts are still actively scanning, but they don't see it. Now, I looked at a couple different ways to solve this problem, and unfortunately, what I would have to do is broadcast my current needs through the signal network. And I decided not to do that because I use those signals for a lot of other things. So what I did instead is for buildings that have at least 2 construction items, I made Build Assistant. I'm going to turn that on now. Build Assistant has identified that we were missing a small turret. It's built it in its local assembler. And now we can finally build this Stabby Scout. And there we are. And it's automatically going off to chase some bad guy somewhere. Now, let's take a look inside and see how that happens. It should be very similar to the previous script, just slightly rearranged. Now, I've moved the busy wait up to the front of the code for one specific reason. This way, if I manually tell it to build something on its own, it won't get overwritten by this script. It'll wait until whatever manual production I've set it to finishes, and then this script will continue on its way. So if we know that our assembler isn't in use, then we check to see what our robotic assembler is building, and we get the second register from that, which is not the recipe that it's building, but it's the item that it's currently looking for in that recipe. Then we follow the same logic as before. Check if we can produce it, check how many we have in stock, find out how many we need based on that stock, and if we need more than 0, then we go ahead and set that production. Now there's a few caveats to this. One, there's nothing to prevent overproduction. And the way I handle that for these is that each of these buildings has a storage block right next to it that it dumps the items to. I actually find this to be pretty helpful because it's rare to produce something that I won't ever need again, and if it does happen, I only really end up with 1 extra component. 2, these scripts are a little bit more fragile than I typically do, but the reason for that is that its ability to understand which of the specific builders that you're doing is mediated through this group index. And as far as I can understand, that's actually counting how many copies of that specific component you have in place, not the global index into which components are in your building. And that made it rather difficult. I'll say I was unable to find code where I could say, look at any of the assembler type things in that slot and pick whichever one happens to be in slot 1. That's going to be the one that you're going with. In any case, I hope this has been helpful to you. Have a great day.